Okay, so let's begin by going over the Exam 1 practice problems that I gave you. Like I said, these are problems that came from previous exams. So this will give you a really good idea of what I'm asking for. Notice with all of these problems, the first thing I ask you to do is tell me the equation that you're going to use to solve the problem, and there's points associated with that. So when I say equation, what I mean is write it out in real words. Don't put the numbers in yet, just tell me what equation you're going to use. At a minimum, you will receive the point for writing the equation down, even if all of the numbers that you throw into that equation are wrong. And every point makes a difference, right? So if you write your equation down and you use the wrong equation, you're going to miss the points for the equation. Okay? But if you go ahead and you solve and use in a real-world sentence correctly based on the equation that you gave, I will give you partial credit. Okay, so this allows me to kind of see your thought process and then evaluate on an individual basis how many partial points I can award you. Okay, so keep that in mind. If, as I said in class, I'll never take points off for differences in rounding. If you round differently than the way I round, totally fine. I will go through and I will recalculate the problem based on the way that you rounded, and if you're correct, you'll receive full credit. Math errors, I'm not overly picky on. You will still get partial credit. If I see that you put the right numbers into the equation and then you just, for whatever reason, divided the wrong way, I'm not going to take very many points off. In fact, it'll probably be less than 1 point that I'll take off depending on how, and I'll probably write math error and, As long as you interpret your incorrectly computed number the correct way, you'll get full credit for the interpretation. So I don't want my math problems to be the type of situation where you screw up from the very beginning, you're done, and you lose 10 points. So I do everything I can along the way to give you at least partial credit. Okay, so keep that in mind as well. Okay, so let's start with the first one. Okay, we have this Iowa Women's Health Study scenario, which, by the way, this is a real problem that was taken from the literature. It's a longitudinal study of mortality and cancer occurrence in 41,837 female Iowa residents. One of the outcomes that the researchers were interested in was postmenopausal breast cancer incidence. Okay, so keep in mind right there when you read the problem that we're looking at postmenopausal breast cancer incidence. Always identify the health outcome that is under study. Okay, a couple people had asked, where do you begin in interpreting these problems? Okay, these are real-world scenarios taken from EPI. These are scenarios that you likely would encounter. Obviously the field is going to change, but these are likely ways the data will be presented to you to answer. So note right away what the health outcome of interest is. Okay. After implementing a telephone survey, researchers determined that 569 of the women were premenopausal, 1,870 had had their breasts surgically removed, and 2,293 had never received a breast cancer screen from their physician. The health records of the entire group of eligible women, okay, so that's another key phrase right there, the entire group of eligible women, okay, were followed for 12 years, and complete breast health records were obtained for all women. Okay, that is not a real-world scenario. That was an adaptation that I gave you guys for ease in computing this problem. But keep in mind that you want to look at information on records that were obtained and how many of the records were obtained for all of the women. Because if you don't have their records, what do you know about their outcome status?
Nothing.
You don't. Okay, so if you don't know, were they at risk for being in your numerator or denominator? Mm-hmm. No. Okay, so that's critical information to deciding what your at-risk population is. Okay, you don't know what happened to those people. Okay, here we, in my theoretical world, had complete case ascertainment. A total of 1,085 cases of breast cancer were identified. So you're first asked to calculate the cumulative incidence. Okay, so what's the equation that we use for cumulative incidence?
Number of new cases received during a specific period over total population at risk.
All right, so cumulative incidence is your number of cases over your at-risk population. Right? All right, so how many cases were identified?
1,085.
Good. Okay. Now we need to figure out our at-risk population. I should be rolling. This is fun, remember? It is fun. All right, so what are we going to start with as kind of our baseline?
41,800. 37.
Good. So we've got 41,837. Are they all at risk
No.
for being cases? Okay, so remember, what do these cases represent in this problem?
Postmenopausal breast cancer.
Right, postmenopausal women with breast cancer. Right? Okay. So what do we need to first subtract? Okay, good. If they're premenopausal, they can't have postmenopausal breast cancer. Or no postmenopausal breast cancer, right? They're not postmenopausal. So we're going to subtract the 569 women that were premenopausal. Now what?
Subtract the women who
Is that our denominator?
No,
Nope. Okay, who do we subtract now?
the women who had their breast surgery removed.
Good. Why?
Because they're not at risk anymore. They don't have breasts.
Absolutely. How's that for our denominator? Absolutely. So we have this 2,293 women that were never screened. What do we know if they were never screened for breast cancer? Are they at risk for being in the numerator?
Yeah.
They might have already had it.
Well, they're never.
Remember,
They're not diagnosed.
had never received a breast cancer screen.
So you would, even if they had breast cancer, you wouldn't know that they were in the numerator because they've never been screened.
Exactly. Even if those 2,293 women have breast cancer, we don't know. They're not at risk for being in the numerator because we don't know what their breast cancer status is. Okay, so keep in mind on the bottom of slide 7, somewhere in there, in the rate presentation from last week, there are 3 criteria for calculating a rate that, and I said make sure you know these. I will tell you again, make sure you know those. I'll tell you right now that will be a multiple choice question on the exam.
Rate.
The 3 criteria for the relationship between a numerator and a denominator. Make sure that you know those forward and backwards. Okay? So in order to be considered a case in this study, they have to have received a breast cancer screen, right? Okay, so we're going to subtract them. Good, excellent. Okay, so what's our denominator?
37,105.
Okay, so what did you calculate your cumulative incidence to be?
.029.
Yep. It's actually
2.
2924. Okay, so now we have this issue of 10 to the n, which I still had a couple of questions about from email this week. Okay, so what do we talk about in class were sort of the critical things to think about or the important things to think about as far as deciding on your 10 to the n, realizing, of course, that it's arbitrary.
Depends on your population.
Okay, it depends on your population, so how large your population is. Okay, this is a pretty large population. I mean, it's, you know, women living in Iowa. It's over 41,000 women that were included in the study. What else?
You want to make sure that your number makes sense. So if you have a lot of zeros before you're getting to it, you want to make sure you're trying to get to like a whole number.
Good. You want to try as best you can to get to some sort of a whole number. Okay, or at least, even if it's not a whole number, at least not reporting a fraction of a person in your per. Okay? So here, what might you recommend that we multiply by?
You know, by 10 to the third.
Good. So if we do times 10 to the third is 1,000. That's going to give you 29.24. What?
Per 1,000 person.
29.24 what?
Oh, I see. Okay,
Breast cancer. Postmenopausal.
Postmenopausal cases of postmenopausal breast cancer per 1,000, or eligible women, some people will say.
So it doesn't matter that it's been 12 years,
When you,
that whole time frame, because it says the number of cases of disease during a specific period of time.
yeah, that's your study time.
Okay.
If you were actually analyzing this data and if you were to go back and look at the stats, yes, year of diagnosis would be included in the statistical model. And you would use pretty sophisticated analytic techniques for actually determining association. So this is really just to get an idea. This is a descriptive statistic to give you an idea of what the rate of breast cancer diagnosis, postmenopausal breast cancer diagnosis was in this population.
But would it be okay to say, add to the end of that sentence, eligible women diagnosed over 12 years?
Sure. You can say in Iowa over 12 years. Really, you want to try to be as specific as possible. Okay, is everybody okay with that one? All right, so in the next question, you are asked to calculate the incidence density of postmenopausal breast cancer. Okay. So how does our incidence equation change when we're looking at incidence density? So ID equals
Number of cases.
over
Total person time.
Okay. So we have the number of cases over the total person time of observation. Okay, so how many cases did we have?
1,005.
Now, how do we figure out our person time of observation? So in
They all-
order to do that, we have to go back to our original problem. And what are you told about the follow-up? There's two important pieces of information there.
This over the entire group.
Good. So we know the
Followed for
entire
12
group.
years.
So this is all the women, right?
Mhm.
Good.
Were followed for 12 years.
Good. So we know that there is 12 years of follow-up for each of these women. Each of these women contributed 12 years of follow-up.
Even the premenopausal ones?
No, this is just the eligible. So
Okay.
the health records of the entire group of eligible women. Yes, if I had not have said eligible women, then you really wouldn't be able to answer that.
So you're just multiplying the denominator by 12.
Absolutely. Perfect. All right, so we have 37,105 times 12 years, which is equal to what?
445,260.
Okay. Okay, so what does that give you when you do the math?
0.002436.
Okay. Now we have that pesky 10 to the n to take into account here. So here that 10 to the n conversion is going to put us in terms of person time of follow-up, not in times of actual people. Right? Okay. This is sort of the simplest example that we would come across in terms of incidence density because everybody was followed for the full amount of time. Okay, we know that in real research this wouldn't be the case. We might have some women that were only followed for 1 year, some for 2 years, some for 3 years. If that was the case, we would go through those steps that we took in class of figuring out what the total contribution was. Okay? Here we don't have to worry about that because everybody was followed up for 12 years. Okay, so a lot easier computationally than what the example was in class. Okay? So here we need to decide on the 10 to the n. Okay, that's going to turn our number of cases into per something of person time observation. Okay, here it's person years is what person time is. So let's do 1,000 again. So we're going to have 2.4 cases per 1,000 person years of follow-up.
Do you have to use the same 10 to the n
Nope.
for each? Okay.
You sure don't. What you would want to use the same person time of follow-up. So this study in Iowa is very similar to a study that was conducted in North Carolina. So if you wanted to compare incidence in person time of follow-up, maybe the North Carolina study was only conducted for 5 years and Iowa was 12 years, you would want to make sure that your person time of follow-up was standard between the two
Your
populations.
10 to the n is standard.
Yes. So your 10 to the n is standard. Yes.
Between two incidences between two questions of the incidence density. right?
Yes.
But you don't have to keep the same 10 to the end between the cumulative incidence rate and the, okay.
Absolutely.
I get caught up on that I need to have
Yep.
the same.
You have, no, because it's all statistically the same. So statistically,
Right.
look over here, this is the same as saying there's 292.4 cases per 10,000 person years.
Okay.
Okay? Or the same as saying 2.924 per 100 person years. Okay, it's all mathematically the same. It's very easy to make that conversion back and forth once you get used to making conversions, okay, into powers of 10.
That's what you told me Thursday. It didn't matter whether you used 1 times 100 times 1,000. It depends on how you word it at the end and make sure
Exactly.
you put your population.
Yep.
Just
As
when you're
long
comparing.
as you word that accurately. Now, today we're going to talk a little bit more about some of the underlying characteristics that can sort of impact making direct comparisons. These are really crude rates. Crude rates are good at the local level, as we'll talk about today. They're not good at making comparisons between geographic areas. So that's sort of a simplified version, but yes, I mean, if this was your computed incidence rate, the methodologies were same, the populations were very similar to each other, they're both agricultural states, then it's a little bit easier to make those comparisons. Okay?
You don't have to specify new, even though incidence is telling you about. new.
Incidence is always new.
So that's just a given, you don't have to say that in your real world.
You can give as much as you want in your real world sentence.
Okay, right.
But I want you to make sure that it's, make sure it's clear that you understand what you're reporting. You go through and, maybe I was to say there were 1,085 that were detected in this 12-year period, but, maybe the situation was slightly changed and women were given historical information and 500 of them were, determined before or were identified before the start of the 12-year period, then you would have to make some adjustments and I could tell whether or not you were reporting incidence or prevalence. So in that case, if you reported the 1,085, but 500 of them were diagnosed prior to the start of the 12-year period, you would be giving a prevalence calculation, not an incidence calculation.
If you
Okay.
included the 500.
If you included the 500, right. Okay. I will always ask you if I expect you to compute incidence or prevalence. That's not something, because they're different calculations, I would never expect you to speculate which one.
So you'll directly say, what is the cumulative incidence?
It will look right like this.
So we'll at least
Well,
get
here
the
I
equation
said-
right.
Yep, what is the cumulative incidence? I gave it straight out to you.
Okay.
Okay? Alrighty, is everybody okay with that first one? A lot easier than the homework?
Yeah, and wait a minute before you move on. I don't want to get lost. I don't know if it's an entering error.
So when it says the
I
per
do that
1,000
first.
person years of
Read that times
follow-up,
12,
Mhm.
and get my answer, and then I do that to that.
is that
But if you can do it on there.
information
So it's not coming
we
out to that.
needed?
So do this
to
one,
do
3, and
this?
then divide it by that.
Right, do that one time.
What do you mean?
12.
Can you be a little more
That,
specific?
you do
No,
that
I don't, I'm not sure what I'm asking.
Okay, we'll take a shot at it. So, if you think about what this denominator means, it means that we followed the population of women for what is the equivalent of 445,260 years.
Because,
Okay, so you could think of it as person 1 was recruited in 2000, she was followed up till 2012, person 2 was recruited in 2013, followed up until 2025. You could go along that way if you wanted. That's kind of what you're thinking of. And you would be following someone for 445,260 years of subjects. But we're condensing this, and we're following more than one up. So we've got overlap in the follow-up periods. But that's essentially what it's meaning. Okay, so you think about how many years of contribution of time. This number is directly impacted by the number of, in this case, women in this study, and by the amount of time that individuals are followed up.
I think what threw is what the per 1,000 person years of follow-up, like what was that needed for? Where does that fit?
So that fits into the interpretation. Okay,
Gotcha.
so if
Okay.
for
okay.
Iowa, we had 445,260 person years of follow-up, and maybe in North Carolina, we only had 200,000 years of person time, or 200 total person years of follow-up. Okay, we know that the amount of time spent following the women in North Carolina was significantly less than that of Iowa. Okay, when you think about a disease like cancer, that a lot of heart disease issues where they tend to be diseases of older people, there tends to be a long latency period. Having longer follow-up is better. It's going to give us sort of an idea of really how close we are to the truth. Okay.
I think it's our 10 to the N that you were asking about, like, why did you pick 1,000? I think,
And-
so if she did a 10 to the N of 4, it would be per 10,000 years of follow-up. If she did a 10 to the N of
2.
2, it would be per 100 years. And she just tried to pick a number that makes sense, so 2.9.
They're all mathematically the same thing. Okay, they're just shifting that decimal point by powers of 10. And if you had have selected, if you had to put 24 cases per 10,000 person years of follow-up, that's mathematically equivalent to 2.4 per 1,000 person years of follow-up.
Mhm.
Does that help? Two different answers to your question. We're going to go over the math problems that were due today for your homework assignment in class 2, so we'll have a little bit more practice with this.
I think I had this problem in class last week of why you were doing this. But like she said, if you're comparing like 2 areas, then you can kind of look at it for the per person years. But I had a hard time understanding why just one piece of data like that, why that would be as
Yeah.
helpful. But when you
Yeah.
compare 2 areas, if you can make the person years, like the 1,000 the same, then you can look at similar data.
Yeah. So it's essentially allowing you to take into account the fact that the real world does not involve complete case ascertainment, and it does not involve equal follow-up times. Okay, so in class we talked about the example of maybe hospital infectious disease transmission between UVA and Martha Jeff. And maybe we were able to maybe at UVA there tended to be more sort of acute short-term stays, but Martha Jeff tended to have longer patient stays. Okay, your risk of contracting a hospital-acquired infection is much greater the longer you stay in the hospital. So an issue such as that person time of follow-up is going to make a difference. It's going to give you an idea of essentially how long people are at risk. Okay, it's just another way of quantifying your at risk. But in this case, quantifying, number of years that people in the study were at risk for being included in the numerator. Okay, longer at risk time, probably going to give you a better idea of what's going on. Okay.
In your sentence for this, do you include at the end, in Iowa over 12 years?
You can. Everyone okay? If I erase this, are we okay? All right, let's move on to the second question. Okay, so in the second question, we have a plague outbreak that occurred in some Asian city during January of 2009. The total population of the city in January of 2009 was 211,462, and city health officials documented a total of 98 laboratory cases of disease. None of them received any treatment. Among the cases, 61 deaths were reported. Okay, so you're first asked to calculate the case fatality rate. So what is case fatality rate?
Number of deaths due to a disease,
Specific disease.
or number of people with the same disease.
Okay, what is this giving us an idea of? I mean, what is this telling us sort of from a practical standpoint? Yeah, how deadly the disease is. The higher the case fatality rate is, the higher the proportion of people with the disease that died. Okay. So, how many people died?
61,
How many cases were there?
98,
Good.
so 62%.
So if we used our 10 to the n of 2, okay, if our 10 to the n was 2, we multiply by 100, we give us 62.2%.
So are you always, for this scenario, trying to make a percent, so would you
Yeah.
always just do by 100?
Usually, yeah. You don't have to, but
But then it wouldn't be a percent, right?
it wouldn't be a percent.
Okay.
Okay, so remember that 10 to the n of 100 is the same as, or 10 to the n of 2 is 100. That's how we put things into percents. We just multiply by 100. Okay, how do we put that in a real world sentence?
The case fatality rate for the plague in January 2009 was 62.2%.
Okay, another version?
62% of the people who contracted the plague in 2009 died.
Good. Both acceptable. Okay. It's really going to depend on your audience. If you were reporting to the general public, telling people really what percent of the people with the disease, okay, terms like case fatality rate really only have a meaning within the medical world or the epidemiology or public health world. To the general public, they might, if you don't know what a case fatality rate is, it might be difficult. But if you're talking to an epidemiology audience, perhaps an audience of clinicians who might be the first people to see these cases, then certainly a case fatality rate is a term that most clinicians dealing in the public health or an epidemiology standpoint are going to have an idea of. Okay, so again, think about your audience. Okay, I think, as I said in that first class, some of the biggest problems